The Smart School Class 7 Science Video Lesson 2. Chapter 1, Heating and Cooling. Today's topic is Heat is about moving particles. We shall be studying page number 3 and 4. Time duration will be about 10 minutes. Resources that we require during this lesson are Science Fact File 2, textbook, notebook, and pencils. By the end of this lesson, you should be able to describe kinetic theory of particles, apply kinetic theory to discuss the motion of particles, and explain how states of matter change due to the movement of particles. First, we shall do a bit of a recap about the previous lesson. You can see three different types of thermometers in this picture on Kelvin, Celsius, and Fahrenheit scales. So 0 degrees Celsius is the freezing point of water. Points A and B, here and here, show this value in Fahrenheit and Kelvin scales. What are these values? The correct answers are freezing point of water in Fahrenheit is 32 degree Fahrenheit and in Kelvin it is 273 kelvins. Kinetic theory. Everything is made of atoms and molecules that are constantly vibrating or moving freely. The motion of these particles produces heat. Change in temperature increases or decreases the motion of these particles. When we increase the temperature, these particles move more fastly, producing more heat. When we decrease the temperature, their motion also decreases and hence their heat energy also decreases. This is known as kinetic theory.
Solids. And what we want to do here is zoom in on the particles of a chunk of matter. Let's say one of these ice cubes here in this glass of water. So if we could zoom in on these particles, we could see kind of what they're doing. Now the molecules of water are just represented by these little tiny spheres here. And they would just be kind of vibrating in place. They're moving slowly because they only have a little bit of kinetic energy. So solids have a low amount of kinetic energy. And one thing we have to remember is that every particle is going to have some degree of attraction with the other particles. And so they have to be moving fast enough in order to break away from the other particles. Now we call these attractions intermolecular forces. And that means the forces of attraction between molecules. So let's describe these particles in the solid chunk of ice. They're in a nice ordered pattern, and we would call this a crystal structure, or in other words, a crystalline structure. That just means there's a nice pattern to the way that they're organized. Solids also have a definite shape. In other words, if we were to drop an ice cube into a glass of water, it's going to retain its shape. It's still going to look like an ice cube. We could also say that the volume is definite. We could measure the height and the length and the width of this ice cube, and we can calculate its volume. So the volume is going to stay the same. So let's recap what we've learned about solids. The particles in solids are going to have a nice ordered pattern. The particles are going to be vibrating. They're moving slowly because they only have a small amount of kinetic energy. They have a definite shape and a definite volume. Okay, let's take a look at the particles of a liquid. This time we're going to zoom in on the liquid water here and look at what its particles are doing. In a liquid, the particles have much greater kinetic energy. They're going to be moving a lot faster. Now, they are randomly moving, so they don't have that nice ordered pattern, but they're not moving fast enough to break those attractive forces. They have the ability to flow past one another, and liquids are not going to have a definite shape, and so they're going to conform to the shape of the container that they're put into. I mean, you could pour a glass of water into a different shaped container, and it's going to fill that container and take on its shape. They do have a definite volume, and so we could use a measuring cup to measure the volume of a liquid. So let's recap liquids. Here's what we've learned. The motion of the particles of a liquid is going to be random. They're moving faster, they have more kinetic energy, and so they're able to flow past one another, but they don't have enough kinetic energy to break those attractive forces. They have an indefinite shape, which means they'll take on the shape of their container, but they do have a definite volume. Finally, we'll look at the water vapor, the gas state, and we'd have to boil the water and kind of zoom in on those particles and see what they look like. The particles of a gas will be moving very quickly. They're moving so quickly that the attractive forces really have no effect. They're very, very spread out and moving very randomly. Gas particles don't have a definite shape. They're going to fill the shape of a container just like a liquid. And they don't have a definite volume either. We can compress a gas into a smaller volume or let it expand to fill a large volume. So to recap what we know about gases, they move randomly and very, very quickly. They're so quick that the attractive forces are almost non-existent. They have an indefinite shape and an indefinite volume.
Changes in states of matter. We can change the states of matter by giving or removing heat energy from it. If we give heat energy, the state of matter will change. Similarly, if we remove heat energy from matter, its state will change again. Some of these state changes are listed as below. Melting. Solid particles move faster on heating and become part of a liquid. You can see an ice cube melting and forming water. What's happening in this picture is that this ice cube is receiving heat energy from its surroundings and is being converted into water. Another change in the state of matter is evaporation. Evaporation is when liquid particles move away from their surface and form gas. This happens when they are heated, their speed increases and they move faster. That is why they break free from the surface of the liquid and form gas. You can see this happening in this picture. This is the surface of the liquid and these particles are breaking free from this surface due to the heat that is provided to them. Condensing is when a gas is cooled and its molecules come closer to form liquid. This glass contains cold water, so when the air around this glass hits its walls, the temperature of the air goes down. We remove heat from the air in the surroundings and that air turns into liquid. Freezing is when the temperature of a liquid is decreased so much that its particles come closer and closer to each other, forming solids. What happens is that we decrease the temperature of the liquid, the motion of its particles also decreases. Due to this, they keep coming closer and finally take the shape of a solid. Mass during the conversions from gas to liquid, liquid to solid, or solid to gas, or vice versa, is always conserved. The total mass during all these changes in states remains same. Quick quiz. When water changes into ice, its total mass remains same, reduces to 1/3, or becomes double. The correct answer is it remains same. We shall now summarize what we have studied so far in this lesson. Matter is made of particles that are constantly moving. vibrating in case of solids, and moving freely in case of liquids and gases. The speed of movement of the particles can be changed with change in temperature, and this change in temperature causes the changes in the states of matter. Loss or gaining of heat changes the state of matter. Your home task is to read pages 3 and 4 of the textbook. Attempt exercise questions 3 to 5 on page 12 of the textbook on your notebooks. Good luck.